Well, it's a pleasure to be here with y'all, and I commend the Science Center and Kim and Derek and others and the university for bringing together young people who are interested in climate change, its impacts, and early in your career starting to build your network of colleagues and scientists that you'll be working with. And you never know, could be for 30 or 40 years. This would be my 35th year of work. And I didn't finish my doctorate until I was 43, and went back to school, and it really changed my life. So those of you who have invested in completing that final degree, or those that are thinking about it, it hugely makes a difference. At the time, I was with the Fish and Wildlife Service, and they said, well, you know, maybe go back to school and finish that degree. And I said, that's what I've always wanted to do. And people said, well, why are you doing that? I was the first female fish and game director in the United States. I directed our coastal management program in Louisiana. You know, I said, why would you want to go back to school? I just wanted to. It was just a dream I had, you know. And everybody said, it's not going to make a difference to you, Virginia. You know, but it did make a difference. So those of you that have invested or are considering investing, it will make a difference. I'm going to outline for you today, this morning, in about 40 minutes of time, or 35 hopefully, an assessment of climate change at the global scale that was just published this year on the impacts part of things by the Ipcc, which is part of the United Nations, and WMO, World Meteorological Organization, team of scientists that conduct these assessments. And then go to the national and focus in on the regional perspectives, and then some ideas at the end, just reflecting on 35 years of things that it would have been nice if someone had told me that when I was your age sitting at the table. Here's the cover of our new Ipcc report. That's in Tuvalu, where nothing on the whole island's over 3 meters tall above sea level, and trying to stabilize shorelines and plan for the impacts that are already underfoot and expected to intensify or be amplified by climate change into the future. So I'm going to give you some highlights first of our Ipcc report. And the reason the Ipcc has such an impact, and these reports are only done every 5-6 years or so, is that it's an institution that is composed of scientists nominated by the governments of all the UN member nations. And we met, I was on the scoping team for this report 2009, so it took us to 2014 to actually produce the report. So we outlined the chapters in 2009, and then we had nominations for 1,217 authors from 92 different countries, and then they were selected down to 243 lead authors and review editors from these countries. We produced a first order draft, a second order draft, and then a final government draft. And we went through all these phases of peer review. And as a result, these basically become the primary source for a global look at climate change and its impacts. That's my author team here. I'm an American on here. No, actually, this fellow from University of California at Irvine was a climate scientist. He was our liaison with Working Group 1 that does the physical climate science. It's one of the most wonderful things I've been exposed to in my career. And so if you have the opportunity to collaborate with people from different nationalities on something that you feel passionate about, do it. This is the meeting that we had in Yokohama, Japan, for all the nations. Like this Japan, when you wanted to speak, there were over 100 nations present. You turned your card on the side. Went 24 hours the last couple of days. Chris Field, our chairman, sat at the podium for 36 hours, went to the bathroom and had lunch. And the scientists, like the U.S. State Department had 5 people there, so they took shifts. But the scientists, you're expected to be there the whole time. So ultimately, people crashed and went to bed at 2 o'clock and got up again to try to cover it. But it was an experience that, again, It's hard to describe, but the outcome of that is a science basis for decision making globally on climate change and its impacts. This is one of the graphics from our summary for policymakers that basically shows that, you know, climate is not just acting independently of other processes that to influence risk globally. That's just the big conceptual model of, and we try to use a risk-based framework for our assessment this time. And it was really cool because we had social scientists. You know, this before Ipcc report, never had a social scientist on my chapter. We had this huge influx of people that knew about people. You know, it was refreshing. And so this risk-based approach, we couldn't have carried out without having the social scientist and the integration of social and physical and biological sciences. It was took a long time to do it, but it was pretty interesting. We found climate change impacts around the entire planet that had been observed and well documented, from the oceans to the poles. And this is from my chapter. We looked at all of the climate change literature, and interestingly, the literature for this assessment was double that in the whole literature since climate change, human influence climate change was first mentioned in the 70s. Okay, so we had all this additional literature to cover, but look where it comes from. These little dots here, this is for North America, the number of pubs in the last decade, the prior decade, and the decade prior to that. This is for the 80s, 90s, 2000s, 2010. But look at what's not covered. South America, Africa, compared, and look where this is the literature by region, and up at the top is literature by author affiliation. We used Scopus, found more coverage there, and did searches for all, and we had a young person that was a volunteer chapter scientist. He wanted to volunteer for work like this. He made a huge difference because he looked for every country in the world and did this literature search. So we could determine, look at the tiny amount. In the developing world, in South America and Africa, less than 5% of all the authors of all that literature come from those countries. So it's still a problem or a challenge in doing a global assessment because, and making it meaningful. I mean, you know how we Americans are. If you have people coming from other countries over here telling us, this is what's happening, this is what you need to plan for. If it doesn't come from in your own voice, in the voice of people that you understand, it's hard to really identify with it and believe it. So this is a huge challenge in the future, I believe, to overcome this imbalance in the geographical source of the literature. Based on the literature that was reviewed since the last assessment report, we found impacts on every continent and in every ocean, and that you could clearly attribute to climate change, no doubt. And you'll look here on the Gulf Coast and there's no sea level rise impacts. That's because the authors of the Chapter 18 that did this, they basically said that, and they're from Princeton, incidentally, Keith, they said that, well, there's too many other factors. They couldn't tease out the climate influence of sea level rise on the Gulf Coast and South Atlantic. Even though we gave them oodles of documents, they said, no, it doesn't meet our criteria. So for these 100+ icons that we have, unequivocal influence of human-induced climate change over the past 100 years. And these are just from the Working Group 1 report. So we've got Working Group 1 is the physical climate science, Working Group 2 is impacts, Working Group 3 is mitigation. That's the way it's organized, and the reports are phased. The Working Group 1 report, this information came out last fall, and then the impact came out in March 31st. Anyway, you can look at the observed temperature change here across the planet, and this is for 1901 to 2012. And look at the United States there, that southeastern part of the United States, including Oklahoma. It doesn't show warming. It's the same thing on the cover of our highlights here. See that blue area? People say, well, why is the southeast cooling? Well, it's not actually cooling anymore, and I'm going to explain that, but it does show up in the Ipcc blue spot as well, or the no change, I should say, spot as well. Looking into the future, this is using two different RCPs, watts per meter square of climate influence at 8.5 and 2.6. This is the observed trend, and there's overlap here. You hear a lot of climate scientists say, well, you know, no matter what we do in terms of emissions or land use change, pretty much the bell has been rung for the next 20 to 30 years. And after 2040, that's when you start to see a difference based upon human decisions, mitigation principally. So we can go the blue line or the red line or somewhere in between. But those are the scenarios that we use for our assessment. This is an RCP, reference concentration profile, 2.6, the cooler emission scenario, but you still have warming, particularly the higher the latitude, the greater the warming. And then look at the higher RCP 8.5 and a much warmer world, and we are indeed tracking above that level, and we have been for the past 15 years. So one of the criticisms of IPCC is that we are underestimating sea level change and the warming that is actually playing out in the observations. Nonetheless, there is a consensus amongst the IPCC that the vulnerability and exposure is, no one is immune to that. It is on every continent, and the poor and marginalized populations are likely to suffer more or feel the impacts more because of the lack of adaptive capacity, governance issues, financing, knowledge. Remember the graphic showing where the literature was coming from, the science basis for making decisions? There is a difference. Nonetheless, even in the developed world, we are seeing impacts. This reminds me of our New Orleans. That's not New Orleans. Even the developed countries are not immune to the impacts of climate change. And in terms of natural systems, I like this graphic from our report that just shows at the different RCPs for 2.6, 6.0, 8.5, that some systems or species can adapt better, those that are easier to move, than others. So extinctions are hard to attribute to climate change, but we know from the literature that there's only a certain pace at which animals can move across landscapes, basically. And the projections, those red dotted line, that red dotted line at the top, is way above the movement capacity for gastropods or trees or mammals, rodents. The average rates of change, this is observed from the Oceans chapter, change in marine taxonomic groups. You can look and see that the distribution changes are consistent, they're poleward. So the distribution change is into cooler waters, formerly cooler waters, and poleward for all of these species, with the exceptions of the non-bony fishes. And these are meta-analysis. This is an analysis of analyses globally. And another graphic about marine systems. This is the change in the catch potential by mid-century compared to the past decade. And everything in yellow and orange and red is a reduction in catch. And the blue, you would think that in the tropics that the adaptive capacity would be greater, but that's not the case. The tropics are going to be impacted tremendously. We have a lot of people, populations in the deltas specifically in the tropics that will be impacted by this change in food availability, fisheries. And In on terrestrial food sources, crops, this is the projections into the future for wheat, soy, rice, and maize crops. Less impacts on soy, but looking across the studies, and there aren't studies basically for 4 degrees or more, which is plausible, but you can see a reduction in the crop yield through the end of the century. So this is why we are confident in saying that there are huge challenges ahead based upon what we understand are the current projections. So it's important to think about reducing and managing risk, because some of these are going to occur because of changes that are already made to the atmosphere, and the fact that, you know, that stabilizing emissions and land use change appears, it's just not likely. If anything, more to intensify into the future. So even in the developed world, we're seeing adaptation that is already occurring, particularly in coastal systems. We've got a lot of examples of adaptation, like this one shown here in the island of Tuvalu. The risk of climate change increase with increased and continued high emissions, of course. And for fire is one of the key drivers of our ways that climate impacts ecosystems. And we've seen an increase in fire frequency and intensity and the aerial extent of fires in the United States over the past 50 years. And that's likely to continue to increase. We call these reasons for concern over here on the right. And in the third assessment report, there were these reasons for concern. We have what we call the burning embers diagram. We've revisited that, and these are the consensus of the scientists from various chapters for unique and threatened species, extreme weather, the distribution of impacts affecting more places more intently, and aggregate impacts and large-scale singular events that really impact systems and people. And as the temperature, this is just to illustrate that as the temperature increases, the greater the temperature rise. Over here you can see this RCP 8.5 here. This is the maximum scenario, the highest scenario. And this is what we have up here. That's the range at which you get into these reasons for concern. The last graphic in our summary for policymakers was added by the country of Norway, Germany, Mexico. Several countries found this graphic and said this needs to be in this very dismal, discouraging summary. We had all this bad news, and they said, but there are options. And so they pull this out. This is in my chapter. And we sat around the table in Brazil one day and created this, showing the we have your biophysical stressors in red, stressing on resilience, pushing in on resilience. If you're familiar with Rockstrom's planetary boundaries concept, it's kind of built on that. And then you have social stressors. So you've got both of these affecting systems, natural and human systems. But we do have choices. You know, there are choices that cascade one way or another along pathways that lower resilience or pathways that can increase resilience. We call these the climate resilient pathways. So there are choices, and they involve two things: adaptation and mitigation. I'll get into that. Next, I want to talk about our third National Climate Assessment. This report here, just released, and this is the summary. The document itself is 1,300 pages. The Ipcc reports, Working Group 1, Working Group 2 is 2 volumes now. I don't carry it with me, and I don't even have a hard copy. It's like this. It's like 30 mini books on climate change and its impacts. So we produced this third National Climate Assessment. The 13 agencies of the Global Change Research Program, shown here on the right, are required to produce this assessment every 4 years, and report to the Congress how climate change is affecting, how the climate is changing, and how it is affecting human-induced and natural processes. Every 4 years we're supposed to do this. The first one was 10 years in the making. So we haven't, this is the first administration that has tried to really meet the deadline, I think. The last administration, there was a lawsuit filed under the Bush administration, and that was what it took to get us to produce a report. Politics somehow really has an influence on climate change science in America. Our previous national climate assessments are shown here. The 2000 report. Remember the law was passed in 1990. We're calling for 4 years. It took till 2000 to produce the first one. And then the second one really didn't produce a wall-to-wall assessment, hence the lawsuit. And so this report was produced, about 100 pages. But it's nothing like this one. This one has reports. There's a report on coast. There's a report on the southeast. There's one on the Great Plains that basically underpin this document. So this is just a highlights document, and a lot more. It was a lot more organized than these the last two assessments. That's just some summary of it there. And the cover, I mentioned to you that the cover of this, I had several people, National Geographic called, a couple of newspapers called, and they said, why is the Southeast cooling? You know, and unfortunately, we put this on the cover, and it's just the average. And if you look at the entire historical record, you know, we had some cooling during the early part of the century, during the mid-century, but now we do have warming in the southeast and the south central region. And so I found this one. This is from the Ipcc report, and you can see up here on the top, this is from Ipcc, the current report, the 3 different time slices, and you can see the southeast here and the south central region. It did warm from 1911 to 1940, but look at this cooling here. This is what changes that regression, okay, to the point where it looks like it's cooling in the southeast. But look at the most recent few decades. So people look at that cover and say, well, that's because of the average that includes this cool period that we really don't know why. Maybe just natural variability, maybe sulfate emissions. We don't know for sure. But we do know for sure that in the past 3 decades now, the southeast, south central region is continuing to warm, is warming like the rest of the country, and at rates that are comparable to the rest of the country. Looking at precipitation change, this is what the historical record looks like over the past 110 years. And you can see the average there over there. And it's getting wetter. You know, you heat up the atmosphere, can hold more water. And we're seeing over land, particularly in the northern hemisphere, more rainfall. And try to explain to a policymaker why we have more drought, but you got more rainfall. You know, it's kind of difficult. So we've produced a lot of graphics that show that a lot of that precipitation is coming down in the form of heavy rainfall events, which are less effective at maintaining soil moisture, runoff to your estuaries, and so forth. So that's part of the explanation. This is from the National Assessment. The rest of these are from the National Assessment Report. And that's just a regional distribution of the change in precipitation. But it doesn't necessarily translate to more flooding. And this is just a historical look at the intensity of flooding, the change per decade. The Southwest getting drier, getting drier and more arid. By the end of the century, this is what it looks like for the United States. And here, I don't know if many of you are familiar with the climate change scenarios. This is using these emission scenarios, this E1. This is assuming, stabilization of emissions over the next few decades. which isn't very likely in my opinion, but still it's an emission scenario, it could happen. And then we have the higher emissions, the A2 that is more comparable to that RCP 8.5. So these are the, look at the changes. This is in degrees Fahrenheit for our policymakers in the United States. And the higher the latitude, again, the more intense the warming, particularly in Alaska, which has warmed twice the rate of the lower 48 states. Tremendous changes are already underway in Alaska. Changes in seasonal precipitation for the end of the century compared to the 70s, 80s, and 90s under the A2 scenario. And so this is one about the warmer. This is currently more what we're tracking on. And so just looking at the annual average change in precipitation is one thing, but if you're an ecologist, you know that that's not what affects systems, natural systems. It's the extremes and the seasonal changes. And in the winter, we see changes in precipitation. Again, the higher the latitude, the more precipitation we expect. Just the way the observed record shows. But look in the spring and the summer, in your growing season, Oklahoma, Texas, the southwestern United States particularly, we expect to see more intense droughts because you've got to couple, this is precipitation change, but then link that with changes in temperature, an increase in temperature plus this, and we're projecting some significant changes in the southwestern United States and in the south central. Look at the summer there where you live. Water supplies are projected to decline into the future. That's by mid-century on the right. Serious changes in Texas and Oklahoma and many parts of the Southwest and even South Florida. We also looked at changes in sea level, and this is from the National Climate Assessment. And the Ipcc still does not, well, there are two different types of sea level rise projections. There's those that are based on the process models, like the one GFGL does, and others where you can model sea level change, and others consider actual rates of change in the paleo record and even in the more recent record. If you look at the literature, it goes up to 2 meters. So it depends on how much risk that you are willing to or want to consider when you're planning a power plant versus the vegetation on Barrier Island. You know, you might want to consider this higher range, even though most of the literature comes into this range here, 1 to 4 feet. This is just an extrapolation, basically, of the current trend using satellite altimetry data. And the rate of sea level rise has doubled over the past 30 years compared to the prior 100 years. And we expect that to continue to accelerate. In the Southeast and the Great Plains, those are the two chapters in our report, and there's a website there. These are the 3 messages from the Great Plains area: rising temperatures affecting water and energy, changes in crop growth, crop yield, and this issue of landscape fragmentation I thought was an interesting conclusion of the authors. This is a spatial change in land use and land cover, 1973 to 2000. You can see the Southeast in general, a lot of changes are underway or have been observed. Temperature distribution changes into the future through the end of the century. No, wait a minute, this is the current, the observed, okay. And projected change, okay. Number of hot days, 1970 to 2000, and into the future. You can see under a lower emission scenario, the B1 scenario, and a higher emission scenario, quite a difference in the number of days. Number of nights also increasing by mid-century. Number of nights exceeding those is greatest in the southern. And in the Great Plains area, tremendous gradient from the northern Great Plains to the southern Great Plains that is borne out in these graphics here that I just pasted in here yesterday. Number of heavy precipitation days. You can see the east to west gradient. And then in the future, more of an increase. You've already got it wetter in the southern part of the south and the eastern part of the Great Plains. But looking into the future, you see even the upper part of the Great Plains increasing in precipitation in heavy events. Number of dry days. You know, as I mentioned, we've got more precipitation in these heavy rainfall events, which basically means there's more dry days, and this is projected particularly intense for the lower Great Plains region. And this just shows that this is another graphic from the Great Plains chapter, an increase in the irrigated farmland. And don't you imagine this will be probably increasing into the future looking at these projections. So competition for water. You know, if you're in natural resources, you know, looking back, boy, if I had thought more about water, I live in Louisiana, we have plenty of water, we thought. Well, now there's quite a lot of fighting over water, surface and groundwater in Louisiana. Looks like it's going to be in the Great Plains too. And one unique aspect of the Great Plains are your tribal populations. Oklahoma, very important here in terms of being a home for Native Americans. And Native Americans, we have a chapter here on indigenous peoples, and it reminds me of some of our conclusions about marginal populations on the edge globally, and the impacts on Native Americans. Yeah, if you're interested, I would encourage you to read that chapter. There are human health effects also that we project in the national assessment, and in both the Great Plains and in the Southeast. This is just a summary of our 3 key messages from the Southeast. This is a ghost forest. I took this picture a few years ago where we've got ball cypress forests that are getting saltier and the trees are dying and the land is sinking. We've got more intense fires and basically a lot of competition for water, as I mentioned. And I'm just going to thumb through these real fast, changing the number of days over 95 through the end of the century. That's the historical trend there on the left, and the projection into the future on the right. Ground level ozone is expected to increase into the future by 2050. This is the plot. Water availability in the southeast is projected to change into the future. And where we have the hash marks here, that's where we have the highest confidence. So over into your area here is where the models project the most consistently changes in water yield, a decline in water yield. Regarding hurricanes, our key findings are consistent with the U.S. of the global assessment for the North Atlantic, where hurricanes form that make landfall in the United States east and Gulf Coast. We've seen an increase in the intensity, the duration, the time, and the frequency of hurricanes, particularly at the categories 4 and 5 since the early 1980s. We think that's in part largely linked to higher sea surface temperature, and we expect to see an increase in the number of the strongest hurricanes in the future and greater rainfall associated with these hurricanes. As a result, we are looking at influences on disasters, and this is just where they have occurred in the past 30 plus years. And you can see the number of events there. So your area is impacted by a lot of these weather disasters, including drought, though. Drought is included in here as well. Our top messages from the national assessment is climate change is not just a problem for the future, but on into the future. We're already seeing the effects, many aspects of our lives are already, and we have this evidence now that we can report, and we have the opportunities to prepare. The way to reduce the impacts, of course, are twofold: either mitigation to reduce the greenhouse gas emissions or the concentrations of greenhouse gases by enhancing sinks, or to take actions that can reduce the impacts or enhance the positive effects of climate change. And many communities, like this one in South Florida, are already developing adaptation strategies. I'm going to end this with some examples from natural resource perspective, which is my background, and the only thing I can attest to personally. You know, I've signed permits for this sort of thing in South Louisiana before we knew that our coast was falling apart because of a number of influences. And so reducing the non-climate related stressors on systems, in my case it was the coastal systems, dredging of oil and gas canals directly to the Gulf, the Gulf of Mexico, that allowed the salt water to get up here even faster into the marsh. Now, knowing what we know now, if we'd only known it 30 years ago. Reducing the risk of fires, you know, fire management. Managing the fuel loads in your forest is something that is a no-brainer. And even in the marsh. We burn the marsh in South Louisiana for the same reason, and also to enhance the production of fur bearers. Preventing and controlling non-native species. I mean, I don't think you can prevent and control non-native species. That may be a good, concise way to say it, but, you know, here, for example, this critter here, that's a nutria. Castor corku, and he likes to eat young trees. So when we do our bulk cypress plantings here, we put them in tree shelters. So preventing their impacts on our restoration efforts was pretty cheap to do. Maintaining healthy, connected, and diverse fish and wildlife populations. When you're importing wild turkeys, for example, the more genetically diverse, the more capable they may be in the future of withstanding the stresses that we expect. Not relying solely on historical weather patterns. You know, I don't know if any of you are duck hunters or not, but we got in a habit. You know, we had a certain bag limit, and you know, when we told hunters they couldn't kill as many green teal or whatever. Well, they didn't like it. But when we showed them the data of the trends in the population and in the Mississippi Flyway, where most of the waterfowl hunting is most successful, you know, they understood that we had to consider these changes in setting, these seasonal oscillations or interannual changes in climate and how they affect the breeding grounds, for example. So the old data, you may be used to hunting under those conditions, but that's not the conditions of today and not likely to be the conditions of tomorrow. Same thing for fisheries. You know, adjusting your fisheries harvest and yield models. You know, you can't just take the one that was published in 1970 and say, okay, we're going to have this number of red drum or speckled trout are going to be harvested, because it's likely conditions are different. So the sustainable yield is probably different than it was when that publication came out. So monitoring is hugely important in this environment. Establishing corridors for species migration. In the lower Mississippi Valley, this is in Mississippi, you know, this is the sea of agriculture. And so how can species migrate? And remember that one up from Ipcc where I showed they could keep pace with climate change or not? In this environment, you know, how do species that aren't as mobile actually move? So facilitating migration is one thing that is underway in some places. And finally, factoring our understanding of processes, natural and human-induced, into management. You know, understanding, for example, in San Diego, one of our USGS young scientists here, measuring accretion rates in the marsh. You know, understanding what areas are most vulnerable, and then factoring that knowledge into our management. And monitoring, once you get into the job, you know, the longer term positions in government or management, you'll see people don't, it's not, interesting for Congress to fund monitoring, apparently. But that's what you have to really be able to do adaptive management. You have to have good monitoring programs. So in conclusion, a couple of slides, some thoughts about what I would do differently as a resource manager. I would focus more on water. In the United States, wall to wall. In the northern latitudes, even though more water is likely in some parts of the country, like Alaska, I would still be focused on water and changes in hydrology. We have over 300 dams in the Mississippi Valley, big dams in the drainage tributaries of Mississippi River. Knowing what we know now, try to get that river back in its delta. We've levied it off, and it's part of the reason we're losing most of our coast in Louisiana. Focus on inventory and monitoring. I started what was called the Natural Heritage Program in Louisiana about 20 years ago. And we inventoried everything, but we didn't monitor. We had all these things mapped, but now we're starting to monitor the status of threatened and endangered species, for example, species on the edge. Developing predictive tools. You know, when I was your age, we thought were status quo. We didn't know that things were changing so much. And now, if I had to go back and take different courses, I would try to take some predictive modeling courses and so I could understand the output of some of the tools that we're getting. Understanding disturbance more. Again, these events that perturb systems and where systems reach tipping points and thresholds. These are probably all in your portfolio of things you understand, but they weren't for me when I was in school preparing to lead and pursue a fish and wildlife career. Taking a more dynamic view of systems. And finally, education. I would say that this last thing here, back to it, this education, if I had $1 to spend as a fish and wildlife manager, as a coastal resource manager, as a governor, whatever, that's where I put it. Education. Because I think, and I've been in a lot of real contentious situations in my career, and if people have the same knowledge of what's happening and a view of the trends and what's likely in the future, people you can come together on making decisions. So an educated public, especially on this topic, climate change, is really important. And some suggestions I would have about, looking back over a 35-year career, some things that made a difference to me. Number one, having good mentors. This lady here was my high school marine biology teacher. And every Friday, we couldn't wear pants to school back then. We had to wear skirts. That's me, 1967, I guess. And but she took us to the beach anyway. And in our skirts, we stained the coast. When I was in southern Mississippi, I knew more about our coastal species than the people teaching it. And I loved it. It was so fun to have that basis. But it was all because of that lady there. If it weren't for her, I wouldn't be doing what I'm doing. I wouldn't be standing here today. All because of that one person. But mentors are not just important in your early career. Looking back on a career of changes and places that you can go, picking good people to work with, people that you can trust, that have your back. Bob Stewart, the Wetlands Center Director, lured me away from state fish and game and basically told me what matters most, what you're doing now, and I was a cabinet member for the state of Louisiana, Director of Wildlife and Fisheries. Somebody can come right behind you and undo everything you did because of politics. Science doesn't change. Science is there. The truth doesn't change. Facts don't change. So he was a mentor to me when I was in my 40s. So always seeking out people that you feel that you can associate with and learn something from, and people who can challenge you and teach you. To this day, I'm hoping that we have a new director Our existing associate director for climate and land use change went to work for the Smithsonian. And I told our congressional affairs person the other day, I want somebody that's an expert. I want to learn something. I want somebody that can challenge and inspire me. So find those people, you know. Pursue your passion. Your first job. I went to college, got my master's degree, and my dream was to be a biologist for wildlife and fisheries for the state of Louisiana. I went and had my interview, and they wouldn't put me at the marine lab because I was female. And they didn't have facilities for females at the marine lab. So I went home, I told my mom and dad, I was real disappointed. But the guy at Wildlife and Fisheries called me, and he said, Miss Van Sickle, which was my name at the time, he said, there's a job at LSU Sea Grant we'd like for you to think about doing, because I was the highest person on the list in terms of the grade, but I was female. So anyway, so they made an arrangement for me to go to LSU, and I interviewed, and I got a job there doing some oyster research. And I went home, and my parents said, well, how much money are you going to make? And I said, I don't know. I forgot to ask. It really didn't matter. And later, that professor that hired me, Dr. McIntyre, he called me a couple weeks later. He said, I'm doing paperwork. He said, you forgot. He said, I forgot. He said, and you didn't ask me for something. It hit him that I never asked and didn't care that I was going to make $10,800 a year working for LSU Sea Grant. That was a long time ago. But I never have regretted, you know, taking something to step me off in my career. You know, you'll have choices. And think about what really excites you, what inspires you. And that's where your gifts and your talents most likely lie. You may change tracks a few times. You know, things may happen, surprises, like climate change. Who'd have thought, you know, 30 years ago that this would be something that was a hugely important societal issue that I might help with somehow. You know, be picky on those first jobs. Good colleagues. Be one. Be one. Don't walk over other people to get to where you want to be. Never. Never. What you do to others, and people know about it, that sticks with people in their mind about what you might do to them. So, you know, most of you were raised probably to be a trustworthy colleague, but others maybe not. But you need to try to find someone you respect, and invariably you'll find that they treat other people fairly. And have many colleagues. Keep track of colleagues. The people, the colleagues, the contacts that you make now, I still have friends from being in your age. And we network and we keep in touch with each other. And that network is hugely important in doing my job, and also just in terms of my personal satisfaction with my career. Be a good employee. Always do the right thing. My husband is an elected district attorney in his 30th year. Never had to run for re-election after never had to run for re-election after he was elected the first time. And his motto for his office, always do the right thing. You know, I mean, think about it. Don't take home pencils. Don't take home paper. You know, be honest. When you report your time, be on time. Don't make excuses. You know, and be the kind of employee that reaches down and pulls others up. Inspire your whole organization, and don't, you know, I read an article once about selfishness and self-focus as being a problem particularly for Americans. It's just our culture, you know, just do it. You know, the things we're taught, the mantras we're given. But be bigger than that. Building bridges. When you leave a job, can you go back to that job? That's a good measure of how effective you are at bridge building. It's very important if you take risk, and not everyone is a risk taker. Okay. When I held a couple of cabinet level positions, and I always take a leave of absence from LSU when I would take those as a backup. But sometimes you might step out, and you know, it's really important to be able to go back if you're going to take risk. And I think that some of the risks that I've taken are the ones that I'm most thankful I've taken, the decisions I've taken. Finally, have a life. You know, forget all the rest of it. Have a life. You're young and you're under intense pressure to compete. But looking back 35 years, and I've made decisions upon decisions that favored my family. When I married my husband, I had to move to his district, way up in North Louisiana, and I said, well, I have to make a decision here. My career, man, that's when I went back to work and finished my PhD. You know, I look back at decisions I made about taking care of my family, adopting a baby, you know, those sorts of things. Looking back, I don't think you have to sacrifice your career for having a family. And I have colleagues that have done that. I have colleagues that have said, well, my career is everything. And maybe that is enough for you. But don't feel bad about having a life. Maybe that's a better way to phrase it. Don't feel bad about having a life. And today, the workplace has changed to where you are able to take stop the clock and tenure, okay, to have children. If your university doesn't offer it, demand it. The NRC did a study of 400 and something universities in 2010, and 98 universities responded, and they had more than 2 options to help people have a life, have a family. And one of those was that stop the clock tenure. We have it at USGS where you can stop the clock on your research grade evaluations. So, and if, finally, if you are interested in leadership positions, remember this. Those who know how generally work for those who know why. You know, and that's why it's following your passion is important. Because if you have a passion, you know why about that. You get off in things that maybe make more money, or maybe something your parents wanted you to do or something. I don't know why you might go off on a different track, but you're more likely to understand the why if it's something that you are passionate about, something that inspires you to find the truth, to find the answers, and to find the facts that can make a difference in our world. So with that,